Hi students, today I am going to discussing about how to find out p pi, p pi, d pi, d pi and p pi, d pi bonds in following compounds. See, every couple of years we have the problems on this type of theories. How to solve? First example, sulfur dioxide. How to find out the p pi and d pi or p pi and p pi bonds or p and s sigma bonds. See, first given what is the given molecule? Given molecule is sulfur dioxide. So in sulfur dioxide, first step we have to write structure of the sulfur dioxide. So according to structural aspects, how many bonds we have? We have 4 bonds. 4 bonds mean one is sigma and second is pi and again sigma and pi. So just by seeing this molecular structure, the sulfur central atom has to maintain single electrons, number is 4. It has to maintain 4 single electrons because we have 4 bonds with the surrounding 2 oxygen atoms. So let us see what is the ground state configuration according to atomic number. So 3s2 3p4. According to ground state configuration, we have 2 electrons. We have 2 single electrons. Okay, but according to this diagram, we have 4 single electrons to maintain 4 bonds. That's why whether we see or not, it does not matter. There is a D. So to expand and get 4 bonds, 1 electron transferred from 3p orbital to 3d orbital. So after shifting 1 electron, okay, what we have, the electron configuration 3s2, 3px1, 3py1 and 3pz1. Where is the remaining 1 electron? Already it has transferred from 3p to 3d level. There is a transferred electron. How many electrons? This is known as first excited configuration. So, you understand students? First we have to write ground state configuration. According to ground state configuration, we have only 2 electrons. But we have to maintain 4 single electrons to get 2 pi bonds or 4 single bonds. So, accordingly, we have to maintain 4 single electrons. That's why just we are shifting 1 electron from 3p to 3d. After shifting of single electron, okay, now what we have the configuration, this is excited state configuration. So this is first excited state configuration. This is ground state electron configuration. So let us see how many single electrons. Aisha, tell me how many single electrons? 4 electrons. How many single electrons we have to maintain? 4 electrons. So after shifting 1 electron, how many electrons we have? 4. That's why. So this is the first step. What is the next step? Just to find out what is the hybridization. According to hybridization formula, already surrounding order and group number and number of bonds formed by 2 oxygen atoms are 4 by 2. So simply 2 plus 1, that is 3. 3 means sp2 hybridization. What is the hybridization? sp2 hybridization. Now, hybrid orbitals form only sigma bonds. Already you know very well. We have 2 types of the bonds. One is sigma bond and another one is pi bond. Sigma bonds are formed by only hybrid orbitals, whereas pi bond is formed by only unhybrid orbitals. Now let us see what is the region of the sp2 hybridized region. So this is according to hybridization. What is the hybridization? That it is sp2 hybridization. It means one s orbital and two p orbitals. It is maintained as hybridization region. So how many oxygen atoms we have? Two oxygen atoms. Oxygen atom is stable in -2. It means it is ready to form two bonds. One bond is formed by like this and another bond. These two are sigma bonds. Now let us see pi bond. This is the pi bond. So see, first we have to write the formula and we have to write the configuration. According to structural aspects, we have to maintain 4 single electrons. But actually, according to atomic structure, where we are writing the electron configuration, how many single electrons we have? Only 2 electrons. But we need more than 2. That's why one electron transferred from 3p orbital to 3d orbital. Just one electron shifting takes place. That's why this is first excited state configuration. At the first excited state configuration, we have 1, 2, 3, 4 single electrons. So it is enough. Now, let us see what is the hybridization according to the hybridization formula. We have sp2 hybridization. It means what? One s orbital and two p orbitals are available, okay, to form sigma bonds. It means hybrid orbitals only forming sigma bonds. Anhybrid orbital or pure orbital or atomic orbital forming only pi bonds. Already you know very well. So according to configuration, sigma bond formed by this region orbitals means one s orbital, two p orbitals. Remaining is what? Remaining is pi bonds. So what is the last shell configuration of oxygen? 2p level. Now let us check how to find out what we have the heading. First one, sulfur to oxygen we have to verify. Sulfur to oxygen. Let us see first sigma bonds. Sulfur 3px1 bonded with 2p orbital of oxygen. Next again second bond is 2py1 2py1 2 2p orbital of oxygen. These two are sigma bonds. Remaining bonds what we have, that is again sulfur 3p Z1 to oxygen 2p level. Okay, and again 3d to 2p of oxygen. These two are pi bonds. These two are pi bonds. Which type of pi bonds? P pi and T pi bonds and D pi and D pi bonds. What we have here? These two are sigma bonds. Means PP sigma. So this is a class how to find out P pi D pi and P pi T pi and P and S sigma bonds. Okay students, any doubts we have? Okay.